Matt Reider. I am a junior here at Western, currently pursuing my Bachelor of Arts in Environmental Studies, Policy and Planning. And this is my partner, Neil.
Hi, I'm Neil. I am currently a sophomore here studying environmental economics.
And so what we're going to present to you today is our campaign Hood Rich, which is shutting the sash to save some cash. And we'll start off with Neil.
Great. So, will you change the slides for me?
Sure.
Okay. That's the end. Thank you very much. Alright, so this is the world. I'm going to draw your attention to a small Eastern European country called Montenegro. Montenegro has 618,000 people. Now let's back up a little bit and come a little closer to where we live. And when we get back to Bellingham and Western, Western has about 16,000 people on a good day. Western as a campus uses more electricity, almost twice as much electricity per year than that whole country of Montenegro, all 618,000 people. So this clearly shows how much we really use as a campus and really how many opportunities there are to save. So where does all this energy come from? Or where is all this energy being used? In this chart, you can see the steam usage per building. Our campus is heated on a hot steam, using our steam plant, and the steam is used in each building to heat the air. If you look at this chart, you might not be able to see the legend on the side, but each line represents a different building on campus. There's two lines that rise above all the others by a pretty significant margin, and those are the chemistry and the biology buildings. These buildings use a lot more energy, heating energy, because of their, the laboratory environment requires a lot of recirculation of air, and a lot of this is with a fume hood. So that led us to where we wanted to do our project. We see, huge energy users. It's all being used with these laboratory fume hoods. So what can we do to work on that? So this led us to our Shut the Sash program. Today we're going to talk about what is a fume hood and why does it use so much energy. We're also going to talk about what other universities have done. We're going to talk about what we created as Western's plan to combat the issue. And finally, we're going to tell you where we want this project to go in the future. So first, what is a fume hood? This is a diagram of a fume hood. They're used in the laboratory environment. That front area that's noted as the sash, that's to protect the user. It's both to protect the user from the experiment going on inside the hood, as well as when that sash gets raised and lowered, it will increase and decrease the amount of air that's being pulled through the system to keep it at a safe level. So when that air is being exhausted out of the building, it's coming from inside. So that's taking inside warm, heated air and exhausting it out the building, which means that more new air has to be reheated. So that's really where this whole problem starts. And an open fume hood uses more energy than 3 average US households. So pretty substantial energy usage. And because it's pretty substantial, a lot of other universities have worked to try to reduce these figures. So Matt's going to share with us how they've been able to do that.
All right, thanks, Neil. So we're going to start off with what other universities have done.
Get a little closer.
All right. So Berkeley has created their own fume hood, which draws in air from the top and bottom. This creates an air buffer such as a grocery store would without doors. By changing the way in which the air flows in, they are allowing an open work area for them so that they are not exposed to the chemicals they are working with. Like I said, jets of air are pushed inward at the top and bottom. This pushes harmful fumes into the back and the exhaust, allowing for a safe work area, like I said. Now, while replacing fume hoods is expensive, Western obviously does not have the funds to do so to replace 100 fume hoods. So a better solution for us would be a student campaign to shut the sash. What Harvard has done is they started a campaign which has reduced their sash height from 12 inches to 2. In an interview with the campus sustainability manager over at Harvard, Jamie has told us that she has saved the school $250,000 a year just from going from 12 inches to 2 inches. This is a 10-inch reduction. $250,000 is an immense amount of money. So, how is Western going to save money? With our own Shut the Sash campaign. The previous campus planning studio class here at Western did a pilot test over a 2-week period. Week 1, they, shown here in blue, data was collected based on normal fume hood usage. No habits were changed, no one was told to change any of their habits. It was just keep going at the way they were. Now for week 2, an email was sent out to the lab TAs and the managers requesting all the students to close the sash when they were done using it. As you can see by the red line, steam usage decreased. Now steam usage is our way of measuring the energy consumption here on campus. As discussed before, steam is what heats our buildings. When fume hoods are open, they are drawing in hot air. This air is replaced with cold air and needs to be heated by the steam. With a 1-week difference, the chem building saved $2,200. Just by one email sent out to lab TAs, just by closing the sash when they weren't using it, they saved $2,200. So, how is Western going to continue the savings? Our first step will be gathering baseline data for comparisons. These comparisons will be evaluated against minimum and maximum values, height values, that will have set goals. Okay, the second step is promotion, goal setting, and stickers. On each hood, there will be a sticker with a maximum and minimum height value. The orange zone is bad. This is where lots of air exchange happens. The sash should only be this height during equipment use or setup. Alright, now we're getting closer. The less the sash height is, the less amount of air that is being drawn in. But remember, you should always keep the sash closed when not in use. And over here we have Harvard sticker. They use metrics to give a meaning to their students on what closing the sash does. The minimum and maximum air values are the airflow rates for each hood. And here is a sticker from UC Irvine. As you can see, 50,000 pounds of CO2 is saved by closing the sash on the fume hood. And now, I'm going to hand it over to Neil.
Alright, so we can see that there's obviously a lot of energy that's being wasted and that it can be saved with a little bit of behavior change. It's happened in many other universities and is continued to be very successful. But from some of the universities that have done campaigns to shut the sash, one of the difficult things is to try to continue to educate and remind people to shut the sash. So the most effective way that we found for that to happen is through the use of a competition. So heading back to Harvard's example, this is outside of every single lab. And what they did is they shut all the sashes and they said the flow rate, if you guys kept the sash closed at all times, would be 5,000, it's in CFM. They opened them all up, they said 10,000. So this was individually determined per lab. Then they compared that to the baseline data and were able to give people a goal to shoot for. So say you guys could get at 5,000, because in all reality you might be using the hood for, even if you're using it for an hour, that's still a tiny fraction of the day. So theoretically you can get really close to your minimum. So they would set goals, and for the teams, or for the individual labs that met their goals, they got entered into a raffle for monthly pizza parties. This has proved to be very effective for the, compared to universities that haven't had a reward system. It's just not on the top of people's minds. So monthly pizza parties were awarded for people that met their goals, and then every quarter or semester they would take everybody that met their goals. So not just one lab, they took everybody that met their goals that quarter and invited them to a big shut the sash wine and cheese party. Overall, this cost Harvard about $2,500 every year. They've been doing it for 5 years, and they've been saving $250,000 every year. So although it might seem a little weird or like a little much to have a wine and cheese party, it's proven very effective, and other universities haven't seen as much of a savings without it. So next, Matt's going to talk about what we've calculated the savings at Western to actually be.
Alright, so what could our potential impacts be with this Shut the Sash campaign? Well, with the price per cubic foot of air to heat here in Washington, it costs $3.37. With a 10-inch reduction in sash height, this would reduce flow rate by 431 CFMs. Take 431 and multiply that by $3.37, and that is well over $1,400 per hood per year. Now, if we take this program, implement it with just 75 fume hoods here on campus, we could save over $108,000 a year. That is a ton of money.
And this is, we said 75. There's 198 fume hoods on campus, but there's a lot of reasons why not all of them could be as successful because of their use patterns and other influences. So this is on a conservative edge if we were to continue with this program. So what do we do from here? So we've outlined a campaign, but one major part of that is actually implementing the campaign. A difficult part of this implementation is trying to continue to keep this program running. And in order to do that, it would need to have somebody to take that position, that leadership position, and that's going to stay at Western for longer than a student might. When talking to the Harvard sustainability coordinator, she said that she thinks that the outreach is key. So all of keeping that interaction is really important. And she said that when they fall behind for even a month or two, if they forget to send out their reminder emails to shut the sash, that they can see that in their trends. So it's important to stay up on this, but it clearly has a large payback. Another thing that we didn't cover very much in our project that has a huge impact is, let's say we do biology and chemistry. That's where we focus most of our attention. There's still 61 other fume hoods on campus. A lot of these are older and outdated machines, and there could also be large impacts from a study looking at those. So, just a reminder, Hoodcat is watching. We like to incorporate